Hello everyone. Welcome to the solution of LeetCode problem 1443, named minimum time to collect all apples in a tree. In this problem, we are given a tree and rooted from 0, and each of the vertex or node has some of the apple. Now our task is we have to find the minimum time we need to collect all of the apple here. So here, let's consider this first example. The root is 0, which has two children, 1 and 2. 1 has two children, 4 and 5. And 2 has two children, 3 and 6. Now, node 0, if we start working from node 0, we can go downwards in the left side, then again in the left side, then we have found apple in the 4, then we can go up, then go down, then we find the apple in 5, then we can go up, then down to the node 2, then go up. So here you can see that there are in total 8 steps we have covered. Alternatively, we can start the journey from the right subtree. That means we can go 0 to 2 and 2 to 0 and move the left part simultaneously. So here in both of the direction, we need basically 8 minutes to cover or get all of the apple from the tree. So here we are given a undirected graph or undirected tree, and we have to find the minimum time we have needed to get all of the apple. I hope you understood the problem statement. Now let's move on to the algorithm. Now here, to understand the algorithm, we have taken the same example. Now, let's understand how basically we can solve this problem. The first intuition comes into mind that this is a graph traversal algorithm. That means we are currently presented at the root node and we have to travel the graph and collect the apple. So as it is a graph traversal algorithm, we can solve it by using DFS or BFS. So here we are using the depth first search to solve the problem. So let's look how the DFS basically work. Initially, we start the traversal from the root node, which is 0. Now from 0, we can go left. Now from 1, we can go left. So here we can see that the node 4 has apple. So the time needed to get the apple is 0, and we will return from the node 4. So here as node 4 has an apple, so it will take 2 additional time to come 1 to 4 and go 4 to 1. So here node 4 will return the value 2. Now from node 1 we will get to node 5, and node 5 it will also return the value 2, 0 for the plucking, and as node 5 has the apple, it will take 2 additional time to get down from 1 to 5 and get up from 5 to 1. So the left part of the node 1 is returning 2, the right subtree of node 1 is returning 2. So what will return the node 1? So node 1 basically return the minimum time of to collect the apple where node 1 is the root. So basically it will return the minimum time to collect the apple into this subtree. So here as the children of the node 1 has the apple 4 and 5. So node 1 will return the value its left subtree value 2 plus its right subtree value 2 plus additional 2, which is time needed to come from 0 to 1 and get back to 1 to 0. So here, node 1 will return the value 6. Now we are again at the node 0, and from node 0 we will get back to the node 2. From node 2 we will get back to the node 3. So node 3 does not have any of the apple, so it will return with the value 0. From 0 again we will get back to the node 6, and from node 6 we will get back to the 2. Again it will return 0 because 6 does not have any of the apple. But for the node 2, as it is having an apple, it will return the value comes from its left subtree, which is 0, plus comes from its right subtree, which is 0, plus additional 2. Additional 2 is the time needed to come 0 to 2 and 2 to 0. So here it will return the value 2. Now the 0 will return the value 6 plus 2, which is 8. That means we need total 8 minutes of time to take all of the apple where the graph rooted at the 2. And basically, this is how the DFS algorithm works. The overall time complexity of this algorithm is big O of n. I hope you understood the algorithm. Now let's move on to the code. In this problem, the code is pretty simple. At first, we are given a function named meantime, which has integer n, vector of edges, and has apple. That means this array will determine which node has the apple or not. Now, we are taking a adjacency list and a vector visited. Now, for each of the edges, we are building the adjacency list here. Now, we are returning a DFS function which has the current starting node 0 with the adjacency list, visited array, and has apple array. Now inside the DFS, for each of the node, initially the distance is 0. Now we are making visited the current node, and for each of the child, if the child is not visited, we are calling the DFS function on the child and you store the return value into the time variable. Now, if the current child has an apple, that means we have to add 2 with the return value time and add the value into the distance and make the has apple of node is equal to true. Finally, for each of the node, as we have calculated the distance for each of the child of this node, we have to return the distance. Finally, the return value of the node 0 will be our answer and we will return it. I hope you understood the code. Thank you everyone for watching the video. We will get back soon with another LeetCode solution.